Hello again. So, time for something a bit geekier than usual. My water tank has a submersible sensor on it. I call it that soap on the rope sensor, that kind of when it hangs down, it connects to tell you that the tank is empty, and when it floats to the top, it connects another pair and it tells you that the tank is full, which is great, but it has moving parts. And I don't really like it because I actually want to know how much water is in the tank. And the reason behind that is that pumping water with solar power, well, it takes a lot of power. So I only want to pump water if it's actually necessary. And I also need to control the well pump and another pump for pressure. So I really need to know how much water there is in it. So I've got myself one of these. It's a waterproof ultrasonic sensor. It's like the sort you have on the back of your car that beeps when you get close to something when you're parking. And I reckon I can make quite a nice little level sensor with that. So, geekier than usual, but yeah, something different. So this is the ultrasonic sensor. This is a little interface card that comes with it, which works off 5 volts. I've got a Raspberry Pi 2.0, which has got Wi-Fi on it, and it's a proper little computer. And it also has lots of interface ports. So this will be great. I can hook that up, and it can talk on Wi-Fi to the little computer that's in the workshop. Now this works on 3.3 volts. This is 5, so need a little bit of bodgery to make that work. And this is a little voltage regulator that will take 24 volts in, and it'll give me 5 volts out, which will feed this, and it will also feed this. So there's a few things to do. So the Pi. Voltage regulator, ground, and 24 volt, and that'll give me ground plus 5. Okay, for this little interface card, I'll call this what should we call it? Let's call it sonar. This needs a 5 volt, and it needs a ground. Now there's different ways of hooking this thing up. The standard way is the Pi sends sonar a signal, and that makes the sonar do its measurement, and then it sends back a pulse, and the width of the pulse is proportional to how far away the thing is, which means you have to just time the duration of the pulse. Now Pis aren't really very good at that because they don't have a proper real-time operating system in it. And I think everyone's missing a point, because this has got different modes of working. And one of them is a serial mode. So the Pi sends it a serial command, which says start recording. And the sonar replies with an actual measurement, and all the measurement is done by the hardware on this board, so it's going to be a hell of a lot more accurate than trying to time a pulse. But the problem is you have 5 volts coming out, and this is only a 3.3 volt signal level. So we stick it through a voltage divider, which is basically 2 resistors, one connected to ground, one connected to that. You send it into the receive. Now this at 3.3 volts is 2/3 of 5 volt. So if we run something like a 1K2 resistor there and a 2K2 resistor there, this input voltage will never exceed the limit for the Pi. so I can get serial comms going through it. You can send 3 volts in as a sonar trigger, because anything above 2 volts this will recognize as a logic high. Coming back, this will send out 5 and we'll get 3.2 volts coming into the serial. So that's that. And the sensor, this thing, plugs into the back of the board. So that's it. Obviously, the Pi has Wi-Fi, so it can just be talked to by the other Raspberry Pi and it'll give a measurement. And of course, you know the dimensions of the water tank. I'll measure that, and with that you can turn the measurement into volume. Yeah, so a waterproof tank level sensor, looking online, you can get them for like 150, 200 bucks. This thing, the sensor's like 10 bucks. One of these little Raspberry Pi things is, what, 25 bucks? And that's it. Just a little bit of code. So we'll see how that goes. I'll prototype it out and test it. Okay, so here we have it on my little prototype board. I've got the Pi 2 going into a little header. This is a sonar like interface card. This thing over here is the sensor itself, which is waterproof. There's a mains to 12 volt power supply, and there are 2 of these little DC-DC converters to give me 5 volts. And here are just 2 resistors that you need to allow the 5 volt serial connection to work with the 3 volt Raspberry Pi. And it works. One thing, the sonar sensor makes a lot of noise on the power supply rails, too much for the little Pi to tolerate. They do like a clean power supply. So I just used 2 of these little things. The 5 volts of this supplies the sensor, and the other 5 volts is just for the Pi. And these are tiny little things and they're cheap, so it works great. And it means I can just give it anything up to 36 volts. I think it's like 9 volts to 36 volts, and it'll give me 5 volts out. So here we have it running as a little daemon. I'm logged into it. And there's a client that talks to it over the Wi-Fi from a different machine. And once a second it spits out data. The connection itself is via a WebSocket, so you can write a little client that will just go and fetch a value from the daemon and then go do something with it, or you can just tweak the client so that it streams the data and you get live updates. Yeah, so now we know it works. I'll build it into something a little bit more resilient and go and install it up north. Finished thing with the ultrasonic sensor, and this is small enough to go into a waterproof enclosure on the back of the workshop. So we have a Raspberry Pi with 4 relays on it and 4 opto-isolated inputs, so it can control things. You can switch them on and off, and it can sense stuff. I've also put a GPS module on it, which is a little plug-in dongle, mainly so that it can synchronize with time, but also so that it can know where it is. Because if you know where you are and what time it is, you know when the sun's coming up, you'll know where to point solar panels, all sorts of stuff. And it makes a Wi-Fi hotspot, sorry. And if you plug it into Starlink, then you know you've got Wi-Fi through the place. So it's a lot of things from not a lot of power. So, here we go. Now I think I'll do this with a screen grab, but you can do things like turn pumps on and off. You'll see the little relays turn on and off when I click the buttons. So there's one for the well pump. There's one for the water pressure pump. And it reads the level of the tank. So this little doohickey here is another little Raspberry Pi. It's a Pi Zero, the tiny one with a sonar module on it. Here's the sensor. And the sensor looks down a pipe at the water level. There you go. As I move the sensor, the level changes.